Today I will teach dimensional analysis of class 11 physics. So, by getting into the chapter, I will tell you that dimensional analysis. Dimensional analysis. In it, what does dimensional in this means? Here it is mass. We denote mass by capital M. We denote length by capital L, and we denote time by capital T, and some other dimensions like current. We denote current by A, means ampere, and we denote temperature by theta or angle. You does not understand what is the dimensions, what is the dimensional analysis. For example, we take velocity. Now, what is velocity? Velocity is displacement by time. And what is the displacement? Displacement's dimension. Displacement length of something. So its dimension is L. And time, the dimension of time is T. So it means L T to the power minus 1, or we can write by this m0 L1 T minus 1. Okay, so now you can understand that what is dimensional analysis. Suppose we take another example of momentum. What is momentum? Momentum is P is equals to mv. Momentum is P is equals to mv. The momentum is P is equals to mv. Now, this is mass. Momentum is mass into velocity. Mass dimension is m, and velocity's dimensions, now we have seen displacement upon science means L upon T, or LT minus 1. Means displacement upon time means M into L by T, means ml by T is equals to M L T minus 1, or in second bracket we have writing M L T minus 1. This is the dimensional analysis of momentum and velocity. Suppose we take another example of force is equals to what? Ma, mass into acceleration. Then dimensions of m is m into acceleration. Now, what is acceleration? Acceleration means delta v upon delta t. So m into what is now delta v? Velocity, and L T minus 1 velocity. This one will be displacement by time means LT minus 1 means L by T into D. This T for this time. So this means m1 l1 t minus 2. This is the dimension of force mlt minus. Please learn its dimension. Its dimension is very important of force. Dimension of force is very important. It is used in everywhere. mlt minus 2 to the power minus 2. mlt to the power minus 2. Then is suppose an example we taken pressure. Pressure P. Now what is pressure? Pressure is equals to force upon area. Now what is the dimension of force? Force dimension is mlt minus 2, and dimension of area. Area means length into length means L square. Means length into length means L square. Dimension is m L minus 1 T minus 2. m L minus 1 T minus 2. This is the dimension of pressure. Pressure equals to pressure. If so, you have noticed that if we can know, we have learned the formula, we know the formula, then we can make easily dimensions of the quantities. So next we are going to start. So we are going to start about some dimensionless quantities, such as some dimensionless quantities. Suppose refractive index. Refractive index means v1 by v2. So it is a ratio. So it has no dimensions. 0 L0 T0. It is dimensionless. And suppose we have mechanical advantage. We have studied in class 10 what is mechanical advantage. Load upon effort. It means m0 L0 T0. So it also does not have dimensionless quantity. These are dimensionless quantities. Next is the principle of homogeneity. Next is the principle of homogeneity. Principle of homogeneity. What is the principle of homogeneity? It means that suppose I am directly doing an example or a question that then you will understand clearly. V is equals to A plus BT. Here V is the velocity. Here V is the velocity and T is the time. And we have to find A and B. Dimensions of A and B. Dimensions of A and B we have to find. Then we know that V minus A minus BT is equals to 0. Here something subtracted from something means that this dimension is equals to this dimension. Means dimensions of A is equals to dimensions of V. Means dimensions of A is equals to dimensions of B. Means something subtracted from something means that this dimensions is equals to this dimension. Suppose we say that 5 centimeter minus 5 centimeter means its dimension is same to this one. It's only is subtracted. We cannot write that 5 centimeter minus 5 liter. It's wrong. This is correct. So that is the process. Then dimensions of V is what? Velocity. V is velocity. And the dimensions of velocity is Lt minus 1. So velocity is Lt minus 1. So dimensions of A is m0 Lt minus 1. T minus 1. Then we have to find the dimensions of B. Dimensions of A we have find, but we have to find dimensions of B. Dimensions of B is equals to what? Here we can see B into T. B into T. This means that dimension of T and dimension of T and dimension of B is equals to dimension of V. From comparing from here, it is also subtracted, so each dimension will be also equal. So dimension of B into dimension of T is equals to V. So we can write that dimensions of V into T is equals to dimension of V. So dimension of B into T. T means time. T means time. Dimensions of V is Lt minus 1 and B into dimension of time is T and it is L by T. We can write Lt minus 1 L by T. L to the power minus 1 means L by T. So dimensions of B is equals to L upon T square or m0 Lt minus 2 T minus 2. Now next is that how can we establish, how can we correct equation checking. Equation checking. Here we have to what to do. This is some applications of dimensional analysis. In it, suppose example taken. Some example that S is equals to V into T, where S is displacement, S is displacement, V is velocity, and T is time. S is displacement, V is velocity, T is time. So here we have to check the dimension on LHS is equals to dimension on RHS. So what is the dimension of displacement S, as it is given displacement? Dimensions of displacement is L and dimension of velocity is Lt minus 1 into time. Dimensions of time is T. So here L equals to L upon T into T. T cancel, means L is equals to else. That means equation is correct. That means that equation is correct. So this type of questions can come, that checking the dimensions of LHS equals to dimension of RHS. The next of the type of questions which come is to establish and formula by knowing dimensions. Suppose here is a question or an example. See, force is directly depends on mass and acceleration. It depends on mass and acceleration. So we can write that force is directly proportional to mass and force is directly proportional to acceleration. Force is directly depend on mass and accelerations, means force is directly proportional to mass and force is directly proportional to acceleration. Here we give some power, suppose we let about x and y, and now we combine them and write them as force is directly proportional to mx and ay. After removing the directly proportional sign, one constant comes, which is k. K is a constant. Now we give the dimensions on both the equal side, on LHS and RHS. Force dimension is very important, mlt minus 2. Okay, and constant k does not have any constants are dimensionless. Now mass, what is the dimension of mass? Dimension of mass is m. So mass is m. And what is the dimension of acceleration? Dimension of acceleration is lt minus 2. Dimension of L is lt minus 2. Y, this way we have to write the x power in x and y power in y. Then mlt minus 2 is equals to x l y t minus 2y. So here from here, this one power 1, this one power, so here x power is equals to 1 and y's power is equals to 1 and minus 2y. So we have to equal both sides by powers, is equals to minus 2y is equals to minus 2. So here y is equals to minus 2 upon minus, which is 1. So dimension power of a value of x and y is 1 1. Now what we have get upward, f equals to constant mx ay. So we will write this, f is constant mx a to the power y, m to the power x, a to the power y. Now we will put the value of the x and y. So it will come f k m a. So this is the formula of force. So up to this only this video and dimensional analysis has been finished. So best of luck, study, and please subscribe our video. Thank you.